Hello, I'm Álvaro Calafell, and in this video I will explain how to identify the harmonic problem in electric installations. In previous videos, we learned the fundamental about harmonics, such as their origin, their characterization as of total harmonic distortion and the individual harmonic distortion, and a review of electrical concepts in the presence of harmonics, and some details about the main sources of harmonics. We will now learn how to identify harmonic problems in an electrical installation, and to which level they affect us. Imagine that we must analyze the harmonic power quality of a typical electrical installation where the main grid fits DC motors connected through converters, induction motors connected to frequency converters, lighting equipment such as LED lamps and single-phase nonlinear loads. Moreover, the installation has compensation and filtering equipment connected to it. In order to identify the harmonic problem, first the harmonic distortion ratios for the voltage and currents must be calculated. Those are the total harmonic distortion and the individual harmonic distortion. After that, the results of these ratios must be compared with the limits recommended by the standards. If the ratios are greater than the limits specified, a harmonic problem can appear, and the scale of this problem will depend on the level of the calculated harmonic ratios. Different standards exist. The European standards present the requirements for the individual and the total harmonic distortion of the grid voltage. We also have the American standards, which provide recommendations about the voltage and current distortions. Finally, we have the International Electrotechnic Commission standards, which provide limits for voltage and current distortions related to equipment. In practice, the above-mentioned standards are quite complicated to understand and sometimes to apply. For this reason, manufacturers have summarized them in some recommendations about the distortion of harmonic voltages and currents. The next slide is a summary of the main standards related to the harmonic distortion limits. In these standards, we can differentiate between the limits of the voltage distortion of networks for the correct operation of the equipment connected in these networks. The limits of the current distortion of nonlinear loads are also stated to ensure no polluting equipment are connected to the network. Therefore, we ensure networks free of harmonic currents. All these standards can be summarized as follows. Regarding the network voltages, the total harmonic distortion of the voltage below 5% identifies as no polluted networks. A total harmonic distortion of the voltages between 5 and 8% identifies as polluted networks. Heavily polluted networks are identified with total harmonic distortion of voltages above 8%. Regarding the harmonic currents injected by nonlinear loads, the total harmonic distortion of the current below 10% identifies as non-polluting nonlinear loads. A total harmonic distortion of the current between 10 and 40% identifies polluting nonlinear loads, and finally, highly polluting nonlinear loads are identified with a total harmonic distortion of the injected currents above 40%. Once we know how to calculate the distortion and the limits are known to classify networks and equipment, now we will present the different approaches for the determination of the data to calculate the distortion of the networks and equipment. Two procedures exist in order to obtain this information. The first procedure is from measurements with power quality analyzers. Imagine that we want to determine the harmonic power quality of the following electric installation. First, the voltage at the point of common coupling with the power quality analyzers must be registered, as well as the currents at the terminals of the nonlinear loads and in the lines which connect these nonlinear loads to the point of common coupling. These measurements are transferred to a laptop, where they are processed to obtain the harmonic distortion. These harmonic distortions are compared to the standard limits, obtaining a diagnostic of the electric installation's health. The second procedure is from harmonic penetration studies. To do this, the electric installation must be modeled and determine the harmonic voltages and currents of the numerical resolution of the harmonic problem. The result of this harmonic resolution provides the harmonic voltages and currents in order to determine the total and individual harmonic distortion. By comparing this distortion with the harmonic limits, we can obtain the corresponding diagnostic. This approach will be explained in the next videos.